All right, so another day, another integrals property video. So if we look at this property here, this is what we're trying to understand. So we're saying if we have the integral from a to b of k times f of x dx, we can say that's equal to k multiplied by the integral from a to b of f of x dx, where k is just some real number, so some multiple, some scalar multiple. Okay, so what I thought would be a good idea is we can do an example. So let's just look at this green line I've drawn here. This is actually the graph of y equals sine x between 0 and pi. And so if we take the integral from 0 to pi of sine x dx, we actually, interestingly enough, we get an area of 2. You're welcome to try that out and see why that's the case, but you might expect things to be in terms of pi, but it turns out to be an integer. So I find that interesting. In any case, that's the integral from 0 to pi of sine x dx between 0 and pi. Yep. So what we can say then, if we wanted to find the integral between 0 and pi of 3 sine x dx, so again, some scalar multiple 3, we can take that 3 out the front. So it's 3 times the integral from 0 to pi of sine x dx. But we know that this part here, 0 to pi sine x dx, is equal to 2. So it's simply just going to be 3 times 2, and then that's going to give us 6. So the area is going to be 6. And sure enough, if we graph 3 sine x, that's this blue curve here between 0 and pi. And yeah, you take the integral of that, and you get an area of 6. So it checks out. So yeah, sometimes using these integral properties can be easier than having to crunch the numbers for the definite integral if you can apply those properties. Good stuff. Keep it up.